Hello class, welcome to this lecture on elasticity. So we are now transitioning from basic introductory principles that we would have in both macroeconomic and microeconomic courses. The discussion about government intervention is sometimes in macroeconomics, sometimes it isn't, but generally speaking, that is still microeconomic specific material, but from this point forward, really diverging into and building off of that supply and demand and market model that we talked about before, and digging deeper to kind of understand the true ins and outs of everything related to it. And the first way in which we can do that is by talking about elasticity. So elasticity is going to be talking about the responsiveness of economic variables to changes in other economic variables, but really in this course it's in the context of the changes in economic variables and their impact on supply and demand, or quantity supplied and quantity demanded. So to give you a roadmap of this lecture, we'll define what elasticity is in a little more detail. Most of the discussion is going to be talking about one type of elasticity, even though there's plenty of them to talk about, which is the price elasticity of demand. And so the price elasticity of demand basically will be the one that talks about the relationship between quantity demanded and a change in price, and we'll do a lot of calculations and talk about the determinants related to that. So the midpoint formula is going to be a formula that you'll use to calculate elasticity in a more consistent manner. We'll talk about the relationship between total revenue and elasticity to see kind of how the elasticity can be useful in terms of a decision-making process for a business or a firm. Again, we'll talk about those determinants of the price elasticity of demand, and then we'll finish off the lecture by talking about other elasticity measurements that exist that are relevant to our discussion of supply and demand. It's not an exhaustive list. There are plenty other ones that we could utilize, but we're going to focus on 3 or 4 in this entire lecture. To turn our attention to microeconomics, so as I mentioned, we're digging in specifically to microeconomic topics for the remainder of the term. Microeconomics, by definition, is just the study of the behavior of individual sections of the economy. So one way we can look at this is kind of individual decision-making units. So people, firms, and markets are trying to optimize their behaviors. Firms are trying to maximize profits. Markets are trying to be efficient. And people are trying to maximize overall satisfaction and consumption with the limited resources and scarce resources that they have. That's really what micro is about. Macroeconomics is different. It's taking a study of the economy as a whole. So instead of looking at specific markets or specific people or specific businesses and how they do their business, we take all of the aggregation of those people doing their thing and trying to achieve those things and seeing kind of how that's causing the economy to behave as a whole. So if we were in a classroom and we're looking at a chalkboard or a whiteboard, basically macroeconomics is that entire whiteboard or chalkboard. And even though in a microeconomics class I might fill up the entire chalkboard or whiteboard with notes and calculations and things like that, microeconomics is, say, a specific phrase or a specific bullet point or a specific spot on that whiteboard or chalkboard, and we zoom in and examine it in its detail instead of just kind of taking a holistic approach like we would in macroeconomics. So that's really what you have to expect moving forward in this course. So the first topic that I want to discuss related to microeconomic specific material is elasticity. So this kind of builds off of the supply and demand graph that we established earlier in the course. Basically, we're just focusing now on individual curves and looking at how there's a relationship between the variables that are being graphed on that curve. So on our supply and demand graph, we have price and we have quantity. And elasticity is going to allow for us to measure the responsiveness of quantity to a change in price, or responsiveness of quantity to a change in income or some other variable, both on the demand curve and the supply curve. And it really helps us understand a little bit deeper what's going on with that relationship, kind of how extreme is that law of demand effect, and what direction is the curve going to shift based on the relationship between a good, its price, prices of other things, income, etc., on the overall quantity demanded or the quantity supplied. So in the context of this course, we're looking at it within the context of the supply and demand graph, but in general, there are plenty of elasticities that we would talk about outside of the few that we're going to talk about in this lecture, and really it boils down to just being a measure of how one economic variable responds to changes in another economic variable. So generally, the economic variable is going to be quantity demanded or quantity supplied, and then the other variable can be anything else that affects quantity demanded or quantity supplied, like we talked about in our demand and supply lectures. Now, if you think about the term responsiveness, you might imply that elasticity, like when we talked about the production possibilities frontier and opportunity cost, that it would be the slope of the graph, that it's just kind of the rise over the run of the function. And the reason why it's not slope, and in a way it kind of is, it's still kind of seeing what is the relationship between the change in price and the change in quantity, is that elasticity will not be slope, because the consequence of using slope is that the elasticity would then be contingent upon the units that you're using. So for example, if the price of a product decreases by $3, but the increase in quantity is measured in weight, such as pounds, and it goes up by 4 pounds. But if you convert that instead from pounds to ounces, that means it's going up by 64 ounces. Then if we're taking slope, price is on the y, so that's the rise, and quantity is the run, then you would have a slope basically of 3/4 versus 3/64. And it's the exact same relationship, just using different measurements. But because the unit being used is different, these do not match up. They're not equal to each other. And so to reconcile this, what we're going to do is instead we're going to measure the percent change of the variable relative to the percent change in the other variable. So the relativity there between the previous unit and the current unit is going to be the same in percent change, whether we're using pounds, ounces, kilograms, grams, whatever unit, stone, whatever unit of measurement that you want to use for mass or weight. So for elasticities, we're always taking a percent change in the variable instead of just doing the slope, because the slope would give us inconsistent measurements depending on the units that we're using. Now, elasticities can measure a bunch of different things, as I mentioned before, but the one we're going to spend the most time on is related to demand, and it's known as the price elasticity of demand. The reason why we're doing this is because price and quantity demanded are measured on our graph, on our axes. So we can actually use the same demand curve to understand the relationship and the responsiveness between price and quantity demanded. So price elasticity of demand, so the first measurement, the first variable that's listed in the definition or the phrase is going to be what goes in the denominator of the equation, and that's really what is changing, and that's what's causing the other thing to change. So we talk about causal effects. So when we talk about the price elasticity of demand, we're saying that price changing is causing quantity demanded to change. So the price is the thing that's changing, that's the X, and then the Y that's changing as a result of that, that's being caused to be changed, is going to be demand. And really the price elasticity of demand is just the responsiveness of the quantity demanded to a change in price. And the way we're going to measure that is by dividing the percent change in quantity demanded by the percent change in price. So the thing that's being changed is going to be in the numerator on the top of the fraction, and the thing that's causing that thing to change is going to be in the denominator of that fraction. So for the price elasticity of demand, We're taking the percent change in quantity demanded, we're dividing it by the percent change in price. So we're talking about elasticity. What does that mean? So really, you think of elastic, you think about flexibility, you think about elastic waistbands, things like that. And really, you can think about elastic in terms of that flexibility. So the more flexible you are in your choices, the more elastic the demand or the supply is going to be. So if you're wearing sweatpants with a loose elastic band that you can stretch out, then you have a lot more flexibility in the amount that you can eat or the amount of movement that you have in those pants. But if you don't have that elastic waistband, you have a lot less flexibility, you're more constricted. And that's kind of the concept here, that basically when you have elastic demand, you have flexibility, and when you have the opposite, which is inelastic demand, you are lacking that flexibility. So inelastic means not elastic, essentially. So how are we going to measure this? Well, since essentially what we have is a fraction that's going to result when you divide the percent change of quantity demanded by the percent change in price for the price elasticity demand, or just the numerator divided by the denominator for any other elasticity. If the rate of change of the quantity, so the thing that's being caused to change is changing at a rate faster than the thing that's causing it to change, you're going to have a bigger number in the numerator and a smaller number in the denominator, and that's going to give you an elasticity value of greater than 1 if we take the absolute value. So you could have an inverse relationship between price and quantity demanded, which you always do, and so it's always going to be a negative number. So in order to determine whether that ratio is greater than or less than 1, you can take the absolute value of it. Now, in reality, if you look in textbooks or you look online when a price elasticity of demand is calculated, so maybe for online homeworks, you'll still have the negative sign there. But for simplicity, I always say for the student to take the absolute value, so you know that that negative sign is always going to be there because there's an inverse relationship between price and quantity demanded. That's the law of demand. If you take the absolute value, then you get 1.7 instead of negative 1.7, then it's easier to understand that that elasticity is greater than 1, and so that numerator is greater than that denominator in terms of magnitude, and so you're going to have elastic demand in that case, that the thing that's being caused to change is changing at a rate faster than the thing that's causing it to change. On the other hand, if, say, quantity demanded is changing at a rate slower than price, then we have what's known as inelastic demand. And so inelastic demand says that the absolute value of that product is going to be less than 1. So the actual price elasticity of demand will be negative in all cases. So in reality, the elasticity value is always going to be less than 1 in terms of the number line because it's a negative number. So in order to determine whether it's elastic or inelastic, you need to take the absolute value. And so if you have negative 0.8, well, that's less than 1, and it's also less than 1 when you take the absolute value, so it's going to be inelastic. But if you have negative 2.5, well, that's technically less than 1, but we need to take the absolute value first to determine whether or not it's elastic or inelastic, and in that case, it's greater than 1 with the absolute value, so you would have elastic demand. Now, there are going to be special cases. So when in the rare event, so all of these are rare events, although perfectly elastic demand at the bottom is going to be very relevant when we talk about perfectly competitive markets later on in the semester or quarter or length of time that this course is set for. So unit elastic demand is rare. It's a rare occurrence where basically the percent change in quantity demanded is exactly the same as the percent change in price. And when that happens, then the percentages cancel out and you just get 1. Or in the case of price elasticity of demand, you would get negative 1. So that has some consequences when we talk about total revenue and the relationship to elasticity, but it's essentially a rare case. Another special case is known as perfectly inelastic demand. And so in this case, the elasticity value is going to be 0. And the reason why it's 0 is because the numerator is 0 and the denominator can change by any increment. That demand or that supply is not changing. And so if you think about quantity being in the numerator and that being the measured by the x-axis of the graph, let me draw a quick one right here. So quantity is here, price is here. If quantity is not changing for any change in price, then what you're going to have is a vertical demand curve or supply curve. And the reason being is the price can go up to any amount it wants to be at, but that quantity is not changing, it's not budging at all. And so there can be cases of this. A lot of people think that perfectly inelastic demand or supply implies it's an indispensable product. So like maybe insulin or an EpiPen or some life-saving medicine or something like that. And that is true. But also it could be something that you're completely indifferent to and have no interest in purchasing. So it could be $1 million or 5 cents or given away to you for free, and you have no interest in it. So in any case, you're not going to consume it or buy it. So you could have perfectly inelastic. Well, that was a bad color choice. Let's switch it to a color that you can actually see. So we'll go with this blue. You can have a vertical demand curve that's on kind of 0 at all times, and that's still perfectly inelastic. So it could be complete indifference, or it is something that's indispensable. So pretty extreme differences in context, but the same result. So let me erase that real quick, and then we'll talk about perfectly elastic demand and supply. So if we're talking about perfectly elastic demand and supply, the elasticity value is actually going to be infinity. And the reason for that is because if you change the price in any direction, if we're talking about the context of the price elasticity of demand or supply, then quantity demanded or supply is either going to go immediately to 0, or it's going to immediately go up to infinity, or as much as you're willing and able to produce as a supplier. And so to reflect that, we have a horizontal demand or supply curve. So let's just assume that that's flat and it's not going upwards because I'm incapable of drawing a straight line apparently. So we have a horizontal demand or supply curve. So if this is demand, that's a D, not a P. Again, not the best at drawing. I did take fine art, believe it or not. I did take fine art. I didn't do very well in it. I think I got like a C in it, but I did take fine art at one point in my life. So I apparently at one point in my life I convinced someone that I was good enough at art to be in fine art, and then after that it's been all downhill. Anyways, back to our regularly scheduled lecture here. Perfectly elastic demand or supply, let's say this is demand. If the price goes up by a penny, so to speak, then this says that demand instantly goes to 0. That a penny higher than this, you would not want a single unit, and nobody in the market would either. The other side of this says that if you lower it, then basically demand will go to infinity, or basically as much as the firm is willing to produce. And in reality, at its current price, you could probably produce as much as you want as it is. So there really isn't necessarily an incentive to lower it. But this is going to be very important later on when we talk about perfect competition, because the demand curve in a perfectly competitive market is actually going to be horizontal. So this is something that we'll deal with in a lot more detail later on in the term. So how do we calculate it? Well, it's pretty obvious if I give you percentages, or percentages are given to you, that it's a pretty simple fraction. You just take the percent change in quantity demanded and divide it by the percent change in price. So let's say that quantity demanded increased by 20% when the price decreased by 10% for some given good or service. If that's the case, you're going to put 20% in the numerator, you're going to put 10% in the denominator, and when you divide that out, you get an answer of -2 as your price elasticity of demand. So your price elasticity of demand in that case would be -2. Now the reason why I have these weird little brackets here is that means absolute value. So basically absolute value is just telling you the distance from 0 on the number line. So if it's -50, it's still 50 units away from the number line 0. If it's +75, you know you're 75 units away from 0 on the number line. So what that does is it just makes it a positive number. So that way you can correctly interpret whether or not you have elastic, inelastic, or one of the special cases in terms of demand. So if you take the absolute value, that gives you 2. Well, 2 is bigger than 1 because remember 1 is our threshold for elastic versus inelastic demand. And so if it's 1, or excuse me, if it's 2 and it's greater than 1, then we have elastic demand. So in this case, we have elastic demand, which again implies flexibility. It implies that quantity demanded is changing at a rate faster than price in the context of the price elasticity of demand. Now, the problem with that formula is that your elasticity is going to be contingent upon which direction you're going. So if I just give you numbers instead of a given percent change, which is more likely to be the case, let's say that the price goes down from $6 to $5, and quantity demanded goes from 7 units to 10 units. Well, then you'd have to calculate percent change. So percent change is going to be the difference between the two numbers divided by the previous number. So this is going to be the previous number for each one respectively. So we have price and we have quantity. So the price went down by 1. Divide that by 6, you get -1/6 as your denominator. Quantity goes up by 3 from 7 to 10. You divide that by, subtract that from 7, you get 3/7. So our elasticity is going to be 3/7 over -1/6, which is going to end up being -18 over 7, which is going to be elastic because the ratio is greater than 1. It's basically 2 and 4/7, which is basically 2.6. So -2.6 is greater than, when you take the absolute value of it, it's greater than 1, so we have elastic demand. Now, let's take the same numbers and go in a different direction, because the reality is we're measuring when we go in this direction and we go in the other direction, the same share of the demand curve. So this is a given demand curve, and we're going between 6 and 5, or it's going to be 6 and 5, and 7 and 10. So essentially we're just measuring the elasticity of this phase of the demand curve. So when that's the case, we're going to do the same calculation but in the other direction. And it's the same exact phase of the demand curve, so you would expect for us to have the exact same answer. So before, the answer was -18 over 7. So we're now going in the opposite direction. So now we get 6 minus 5 over 5, which is now 1/5 positive. We get -3 over 10. So we now get an answer of -15 over 10, which is -1.5. -1.5, when you take the absolute value, is greater than 1, so we still have elastic demand. So we can conclude that that phase, that range of the demand curve is elastic, but the answer is different. We got negative 1.5 before, and now we're getting, or excuse me, we got negative 1.5 now, we got negative roughly 2.6 and negative 18 over 7 earlier. Those are not even close to the same. But it's the exact same range of the demand curve. It's the exact same range of the demand curve. So the problem is that if you accidentally flip your numbers, you could potentially get the wrong answer. So to rectify this, to get a consistent answer whether you're going with an increase in price or a decrease in price, is to use this formula known as the midpoint formula. So this midpoint formula, what it is it's basically still a percent change formula. So if I give you two numbers, you're going to have to do a percent change, which is just the new value minus the old value divided by the old value, and then times 100 to make it percentage. But in general, you could just leave it as a fraction and then cross multiply if you want to do it that way, like I just did on this example. So really the only difference between that and what you're doing with the midpoint formula is, instead of dividing by the old value for quantity and price respectively, you're dividing by the midpoint, or the average of the two prices for price and the average of the two quantities for quantity. So an example of this is this. So if we're increasing or decreasing price with the midpoint formula, it doesn't matter because your denominator will be constant. Your numerator is constant no matter what. The sign just flips depending on the direction you're going. So if you're increasing price, then quantity will have the negative sign. And if you're decreasing price, then price will have the negative sign. So that doesn't really matter because it gets distributed through as a negative number anyway. So the numerator is not the issue, it's the denominator. The denominator changed. So when you go up, 7 was the original denominator for quantity, but then when you go down, 10 is the denominator for quantity. So that's where the mistakes are happening, or the differential is happening. So if we want to do this same calculation with the midpoint formula, what we're going to do is we're going to take 6, so we'll go from 6 to 5 again like before. So we have negative 1 over the average of the two, which is 5 plus 6, which is 11 divided by 2, which is 5.5. So that's your denominator. Your numerator is going to be 10 minus 7, which is 3, divided by the average, which is 10 plus 7 divided by 2, so 17 over 2, which is going to be 8.5. So you now have an answer of 3.5 over 8.5 divided by negative 1 over 5.5. And so you end up with 5.5 times 3, which is going to give you an answer of 16.5 divided by 8.5, which is going to give you negative 1.94 is your answer. So you still end up with elastic demand, but the good news is if you wanted to go in the other direction, the denominators for each respective side are going to remain the same, but your numerators are going to remain the same. It's just that the sign flips from the denominator to the numerator, and you're still going to get a negative number. It's going to be the exact same number. So the midpoint formula allows for you to kind of have a foolproof solution to calculating your problem. So please be mindful on homeworks, exams, and other assessments that sometimes it may ask you for the midpoint formula, other times it may not. So if it asks you to use the midpoint formula, make sure that you're using the midpoint formula, because the answer will be different than if you don't. And there might also be a mistake if you don't use the midpoint formula, because it's really contingent upon what direction you're going, because the denominator will change depending on the direction you're going in terms of price or quantity. So let's do another example with the midpoint formula. So we want to find the price elasticity of demand again. So a company has decided to lower its product price from $175 to $150. And when that happens, the quantity demanded increases from 12,500 units to 14,000 units. So if we're using the midpoint formula, we need to take the average of these two numbers and take the average of these two numbers to get our denominator for each respective fraction. So 175 plus 150 is 325. Divide that by 2, you end up with 162.5 as your price in the denominator. 12,500 plus 14,000 is 26,500. Divide that by 2, you end up with 13,250. And then really you're just then taking the difference between 175 and 150, which is going to be negative 25. So you end up with negative 25 over 162.5 in the denominator. In the numerator, you're going to have the difference here, which is 1,500, divided by 13,250. So when you plug those numbers in, you end up with, as I mentioned before, 1,500 over 13,250 divided by negative 25 over 162.50. When you get that, you basically get two decimals of 0.1132 over negative 0.15385. When you divide that out, you end up getting a price elasticity of demand of negative 0.7358, or roughly negative 0.736. Most of the time they round to two decimal places, so hundredths is fine, thousandths is okay as well. You probably wouldn't round out this far, but let's say we do. Now, if we want to determine whether this is elastic or inelastic demand, we could take the absolute value of that elasticity we just calculated, becomes a positive number, and we determine that 0.7358 is less than 1, and so we end up with inelastic demand as our interpretation. And if we were to decide to flip it, all that would change in this entire problem is that that negative sign that we see where it says negative 25 would then become negative 1,500, and you would get the exact same answer. It's just that the negative sign will now be distributed in the numerator instead of the denominator of the fraction. So again, this is really here as a tool to help you have less opportunity for mistake than anything. So even though the formula may seem scary, it's really not. It's just the new value minus the old value divided by the average of the 2 points. The original formula is just new minus old divided by old. Remember, quantity is always in the numerator. Price is always in the denominator. And you're always going to get a negative number because of the law of demand, we're always getting a negative number at any given point when it comes to the price elasticity of demand. So, whether or not we have elastic or inelastic demand affects the total revenue for a business. So, total revenue is just price times quantity. TR is the abbreviation for total revenue. So, it's the amount of units that you sell times the price you sell it at is your total revenue. If we have elastic demand, then if you're a business with elastic demand in your product, then it incentivizes you to decrease your price. And the reason for that is because if you increase your price, again, elastic means quantity is changing faster than price. So if quantity demand is changing faster than price, then that means that if you increase your price, then the amount of people that are going to stop buying it is faster than the increase in price that you're receiving per unit sold. And so you're actually going to have a decrease in your total revenue. If you decrease the price, then the same thing happens, but in the other direction. More people will buy a higher volume of it than before, than the loss per unit that you're selling it for. And so this is the reason why businesses have sales, is because the goal is that the higher volume that they receive, it will more than offset the loss per unit that they're receiving. Now, on the other hand, if you have inelastic demand, it's the opposite. If you have inelastic demand, then if you increase the price, the amount of people that will substitute away for some other product or just not buy as much of it will be a smaller amount than the actual additional revenue that you're getting per unit that you're selling. And so when you increase the price, you actually increase your revenue. And if you have a sale, then you actually would decrease your total revenue because the increase in the quantity demanded will not offset the lost per unit revenue that you were originally receiving before. Now, if we have unit elastic demand, since it's a one-to-one relationship, then your total revenue is going to remain constant throughout that entire process. So again, if you have elastic demand, you want to lower your price. Inelastic demand, you want to raise your price. Unit elastic demand, keep it unchanged. Actually, quite frankly, it doesn't matter, but it won't change in terms of total revenue depending on what direction you're going. Now, is this the only thing that you should take into consideration? Absolutely not. The end of this unit will talk about costs in a later lecture. And really, costs kind of come down to how this is going to be dictated. Because if you decrease your price, you might actually not be able to produce as much depending on your costs. And so this is a way to determine how much your revenue will change. But as we'll learn, firms are focusing more on profits than revenues, at least if they're trying to optimize properly. And so please be mindful of that. This is not the end-all be-all. There's still other things we have to take into consideration like costs. But if you have elastic demand, it's probably better for you to lower your price. And if you have inelastic demand, it's better to kind of increase it. Now, it's important to understand what determines the price elasticity of demand. So these are not elements, meaning that you need to have all of them in one category in order for it to be elastic or inelastic. They're basically factors that we're going to weigh, and the bigger the weight, the more likely it's going to be elastic versus inelastic. So it's interesting to figure out what type of products are elastic and what type of products are inelastic, and sometimes it depends on how you're measuring it. So one of the variables that I omitted from here is kind of the definition of the market. So if you have a narrowly defined market, you might have a different interpretation of the elasticity than if you have a broad market. But the problem is it's not consistent, so that's why I'm not including it here, but it is still relevant. So like if we're trying to measure the elasticity of gasoline versus the elasticity of a gas station's prices when two of them are across the street from each other, there's a completely different interpretation between those two relationships. So it's relevant, but it's not consistent. So we'll focus on the four consistent ones. The first one is availability of close substitutes. So the more available a substitute is, the more elastic the demand that you will have. So it's not saying that it is elastic, it's just saying it's going to be more elastic because it's a continuum. So it could go from like 1.2 to 1.5. So it was always elastic, it just becomes more elastic in that context. So if you think about gas in the context of just what do I put for fuel in my vehicle, well, you don't really have options there. So when I was in high school, I was on the track team, and some of my track teammates, they were the long distance runners, they decided, you know what, we're going to put some mulch in our teammates' gas tank because it's funny. And you know what, that car did not run on mulch. In fact, the car did not run at all because there was mulch in the gas tank. And so the reality is there really aren't many substitutes for the fuel that your car accepts, whether it's diesel, whether it's unleaded, whether it's premium, whether it's vegetable oil. Look it up, it's a real thing. Electricity, whatever the fuel for the vehicle, there really isn't other substitutes available. Now, if we were talking about in the context of gas stations at a rest stop where there's 6 of them and then you're trying to decide between those, well, then you're going to be more elastic in your choice of which gas station you're going to go to based on the price, because you have substitutes that you can substitute with, and they're pretty much perfect substitutes because they have the same gas essentially. So you're going to decide and have more elasticity in that context. You're pretty inflexible with your fuel choices if it's just what do I put in my tank versus where do I go to save money. The second category that's listed here is passage of time. So the more time that passes, the more elastic the demand. So what this speaks to is basically if you have more time to decide on a purchase, you're more likely to be elastic. So this is one of the reasons why when you go to a car dealership, the car dealership is going to be pressuring you. They're saying no pressure, but it's all pressure to try and close the deal before you leave and walk out of the dealership, because they know that once you leave, you have the freedom to not come back or to look at other places and then potentially save money and pit them against each other. So you have more elasticity and choice. But if they pressure you and say, this is the only one we got, that's the one you want, you drove it, you loved it, it could be your car if you just sign on the dotted line and pay exorbitant amounts of interest and lose depreciation if it's a brand new car, then you're going to be less elastic in your choice options. The third category is luxuries versus necessities. So luxuries tend to be more elastic, one, because you're probably spending more, and also because you probably don't necessarily need it, so you're going to be more kind of judicial or kind of prudent about your decision making. Now, if it's a necessity, so not necessitite as I put in the slideshow, necessities tend to be more inelastic, meaning that if I need to complete this product, or excuse me, if I need this product to be able to be successful, then, or because I need it to live, then I'm going to have a little less flexibility in my choice decision-making process. And then lastly, the share of the good in the consumer's budget. So the higher the proportion, so if you're buying a car, you're buying a house, you're buying a significant purchase, you tend to be more elastic because you're going to be more judicious in the process, because you're kind of like, well, I'm not going to overspend. I'm going to kind of check all my boxes, see what other options are out there, make sure I can actually afford it, see what kind of interest rates are out there to make sure that this is the right choice for me. Now, if it's paper clips, you'll just buy whichever ones, because it takes up a hardly a significant amount of your budget, so it doesn't really matter if paper clips double in price. You don't buy them frequently enough. They don't take up enough of your budget to where you're kind of painstakingly deciding where to buy your paper clips, whether it's Dollar Tree or Dollar General or the grocery store or any other dollar store or place, or you just take them from your employer, which is what most people end up doing. So not condoning that at all, and I have not done that. All of the paper clips that I utilize in my current profession and institution were willingly provided by the institution. I did not have to steal them. So do not turn me in, because I have not broken any laws that you know of. So next, let's talk about real-world elasticities. So again, that context matters in terms of books. So if you're buying a book from a bookstore, you're going to have a high elasticity. So if you go to like Barnes & Noble, or when Borders existed, Borders, or other bookstores, the prices might have higher markups and you have a little more flexibility because you're kind of like, well, I have this other option known as Amazon. So, but if you buy a book on Amazon, like their third-party marketplace and things where you can buy used textbooks and things like that, you have a lot less flexibility because you're kind of at the bottom in terms of the price that you can actually sell it for, or receive for it, or pay for it. So there's a lot less flexibility there, so it tends to be inelastic when you're buying something on Amazon versus when you're buying something at Barnes & Noble. Cars are elastic. That probably makes sense considering the fact that they take up a lot of our budget. Coke, this is the drink, like Coca-Cola, is actually elastic, partially due to the fact that it has a close substitute, but it's actually elastic, even though lots of people enjoy drinking it. Grapes that you would buy in the produce section are elastic, but once you, again, comparing again, Coca-Cola is elastic, but soft drinks in general, like Coca-Cola, Pepsi, and Sprite, and Dr. Pepper, and things like that, are actually inelastic. Mainly because maybe it's a source of caffeine or positive flavor, and so you have a little less flexibility. Or maybe you're purchasing them at a restaurant where you're like, I'm going to buy something anyway, so I don't really have a choice over the price of it because I'm just going to get it, or I'm not going to get it. Restaurant meals are inelastic, again, mainly probably because once you're in the restaurant, it's a lot more difficult to just get up and walk out. I have gotten up and walked out of restaurants before, but it is still very hard to do because it's awkward and uncomfortable. Health insurance is inelastic, but probably not as inelastic as you think. Bread is more inelastic. Water is more inelastic than bread, but you would think since water is indispensable for life that it would be super inelastic, but beer is more inelastic than that. Cocaine, so yes, we actually have a measurement of cocaine for elasticity, is actually more inelastic than beer. Cigarettes are even more inelastic than cocaine. Gas is super duper 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 inelastic, mainly because you have nothing else that you can put in your gas tank unless you want it to break down. Sugar is super inelastic, and milk is super inelastic. Those are the two most inelastic things that are identified. Milk and sugar. Sugar mainly because of when you buy it, you just buy it and it's not taking up a lot of your budget. It's a staple. You just put it in your house and you let it. You intend to bake and then you don't bake and then it gets really hard and then you have to buy it again 3 years from now. So, and then milk, it's a staple in your refrigerator, so a lot of people just end up grabbing the milk, throwing it in their cart, and moving on with their day. So it also doesn't necessarily take up a big amount of your budget, so it tends to be super duper inelastic. Other types of elasticities that we can measure is the price elasticity of supply. So again, this is just the responsiveness of quantity supplied to a change in price. So all of the stuff that we talked about before, if it's greater than 1, it's elastic. If it's less than 1, it's inelastic. And the special cases, all of that applies to the price elasticity of supply. The only difference here is that since supply is upward sloping, you're not going to have that negative sign like you did before. You're always going to have a positive elasticity value for the price elasticity of supply. Because as price goes up, quantity supplied goes up, and when price goes down, quantity supplied goes down, and this is really just measuring by how much, by what frequency is supply being affected. So is supply inflexible with its fluctuations? Does it not change much, or does it change significantly when price changes, depending upon the incentives that are being generated by the market and also based on the costs associated with producing that good or service. So if it's low cost, it might be more inelastic. If it's high cost, it's tending to be more elastic. The income elasticity of demand is different. It's again focusing on demand, so your percent change in quantity demanded is going to be your numerator, but now your denominator is going to be income, the percent change in income. And since our graph, our supply and demand graph, is only measuring price and quantity, the income elasticity of demand is going to give us the determination where the sign now matters more than anything else. The elasticity is going to allow for us to identify whether that good is a luxury or a necessity. So again, luxuries tend to be more elastic. So if you have elastic income demand, then we're going to have denoted as a luxury. If it's less than 1, we're going to denote it as a necessity. But the sign now matters, because with the price elasticity of demand and supply, we already knew what the sign was going to be based on the law of demand and the law of supply. But for the income elasticity of demand, The sign determines whether or not it's a normal good or an inferior good. If we have a negative income elasticity of demand, we have an inferior good, because when income goes up, quantity demanded goes down, which would shift the curve. So again, the income elasticity of demand is focusing on curve shifts in the direction of the shift, depending on whether it's an inferior or normal good. So if you have an inferior good and income goes up, quantity demand is going to go down, so we would shift the demand curve to the left. And if we have a positive sign on that, that means that income and demand are shifting in the same direction. So we would have a shift to the right for an increase in demand for increase in income, and a shift to the left and a decrease in demand from a decrease in income. And then the last elasticity that we will talk about is the cross-price elasticity of demand. So remember, income was one of our variables that shifted the demand curve, and then the second one was prices of related goods. And so the two types of goods that we had were complements and substitutes. So the cross-price elasticity of demand is taking the relationship between quantity demanded of the good that's on your graph and the change in the price of that other good. So we're actually measuring the change in quantity of X divided by a change in the price of Y. So this is not the same as price elasticity of demand, because it's not the price of X, it's now the price of Y. And so the sign, again, is what we care about here. So the sign tells us whether there's a substitute relationship, a complementary relationship, or if the goods are just unrelated in general. So if we take a situation where quantity doesn't change when price changes of the other good, then that means that those two goods are unrelated. So if the price of spoons goes up, does the quantity of army tanks change? Probably not, because of spoon prices. So they're not related, so you won't get an elasticity there. Quantity of tanks demanded is going to be 0 when the price of spoons goes up by 1,000,000%. It doesn't matter. So those would be unrelated goods. Now if we have the quantity of iPhones based on the change in the price of Samsungs, well, if the price of a Samsung goes up, then that means that the iPhone is now relatively cheaper, so we'd have an increase in the quantity of iPhones. So if you have a positive divided by a positive, and then if the price of the Samsung goes down, then the quantity of the iPhone would go down. So you'd have a negative divided by a negative. Both cases would result in a positive number. So that's why if this elasticity is a positive value, you're going to have a substitute relationship. Now, if you have complementary goods, on the other hand, you would have a negative sign, because if the price of the complement goes up, then that means that the quantity demanded for the product that you're concerned with is going to go down. So you would actually have one going up, one going down, and you'd have a negative number. So if you have a negative number, then the elasticity is going to be negative.